Hi, Assalamualaikum and very good morning everyone. My name is Tugasan Sumaya binti Marwahidi and I'm from Next 2. So today I will be presenting my project for the course MTES1074 Basic Algebra. So my topic is about how we can use linear algebra concepts in maximizing profit for a small food business. Okay. This is overview that we will discuss together. So we go on for introduction, problem statement, model formulation that we use to solve this problem, and how to solve the problem and the conclusion. So for introduction, as everyone know, mathematics is very important in our daily life. It helps us solve problems and make a good decision. So in this study, we use algebraic concepts such as linear equations, linear inequalities, and linear programming. This is because to create a model that helps make the best decision to maximize profit within certain limits like cost, time, and demand. So next we look for the problem statement. So here's Anna's problem in short. So she runs a store selling laksa and nasi kerabu with limited resources, which is 200 ringgit capital and 360 minutes time. She must prepare at least 15 bowls of laksa and 10 plates of nasi kerabu daily. Each laksa earns 8 ringgit profit and for nasi kerabu is 10 ringgit. So, our goal is to maximize Aina's daily profit. We model this as a linear program and solve for the best combination of x and y that respect her budget, her time, and minimum production requirements. So we look for the model formulation and mathematical concepts that we use to solve this problem. So we use linear equation, linear inequalities, and linear programming. Okay, so now we look for linear equation. So we use linear equations to represent the relationship between the number of food items prepared and Aina's available resources, which are capital and time. So first we have to define the variable. So let x be the number of bowls of laksa prepared each day and y be the number of plates of nasi kerabu prepared each day. So from the information, each bowl of laksa costs 5 ringgit to prepare. Each plate of nasi kerabu costs 8 ringgit to prepare. So Aina's total daily capital is 200. So from the information from this, we can form the first equation, 5x plus 8y equals to 200. So this represents the budget constraint. Next, each bowl of laksa takes 12 minutes and each plate of nasi kerabu takes 18 minutes to prepare. So total available time is 360 minutes. So from this information, we can form second equation is 12x plus 18y equals to 360. So this will represent the time constraint. So these two equations show how the number of laksa and nasi kerabu are related to Aila's total cost and time. So any change in the number of bowls of laksa, or plates prepared will affect her total resources used. So basically, this equation help Aina plan how many dishes she can make without exceeding her budget and time limit. Okay, next we move to linear inequalities. So we apply linear inequalities to represent the real life limitation faced by Aina in her food business. So we can take out from the from the situation several constraints. So for the first constraint is budget constraint. So the cost of raw ingredients for each bowl of laksa is 5 ringgit, and for each plate of nasi kerabu is 8 ringgit. The total daily budget cannot exceed 200. So 5 ringgit for laksa is 5x because laksa equals to x, right? So for nasi kerabu is 8, so 8y. And the total daily budget cannot exceed 200. So cannot exceed, we use symbol less than or equal to 200. So the first constraint 5x plus 8y less than or equal to 200. Next, for the second constraint is time constraint. So each bowl of laksa takes 12 minutes to prepare, while each plate of nasi kerabu takes 18 minutes. The total preparation time cannot exceed 360 minutes. So each bowl of laksa takes 12 minutes, so 12x plus plate of nasi kerabu takes 18 minutes plus 18y. So we use less than or equal to because cannot exceed. So less than or equal to 360 minutes. Next, the third constraint is minimum demand constraint. So Aina must prepare at least 15 bowls of laksa and 10 plates of nasi kerabu each day. So laksa equals to x. So x, we use symbol more than or equal to because the keyword is at least. So we use more than or equal to 15. Next, nasi kerabu. So same like this, same like laksa. So at least we use symbol more than or equal to. So the minimum demand constraint is x more than or equal to 15 and y more than or equal to 10. Next, okay, for the linear programming. So Aina, as everyone know, Aina's main objective is to maximize her daily profit from selling laksa and nasi kerabu. So this can be expressed as the objective function. So the objective function can be written as z equals to 8x plus 10y. So where x represents the number of bowls of laksa and y represents the number of nasi kerabu. So this objective function is subject to all of these constraints. Like before, we already know we have budget constraint, time constraint, and minimum demand constraint. So this is budget constraint or capital constraint lah. So this is for time constraint and these two is minimum demand constraint. So overall, this model represents Aina's goals of maximizing her daily profit while taking into account her real-world limitation in terms of cost, time, and customer demand. So, by analyzing this constraint together, Aina can determine the most efficient combination of laksa and nasi kerabu to prepare within her available resources, 200 ringgit and 360 minutes. So, her method of solution. So, in this section, I will explain the method used to solve the problem. So, first, step 1, we have to identify objective function and constraint. So, before this, we already know the objective function and constraint. Okay, step 2, substitute the minimum value x equals to 15 into the time constraint. So, as we know, time constraint is 12x plus 18y less than or equal to 360. So we substitute the x with the 50. So 12 in the bracket 15 plus 18y less than or equal to 360. So we solve 12 multiplied with 15, we get 180 plus 18y less than or equal to 360. So then we move 118 to get the value of y. So after we solve it, we will get y less than or equal to 10. So this means if you produce 15 units of x, you cannot produce more than 10 units of y without exceeding the available time 360. So, however, from the minimum demand, y more than or equal to 10. So, therefore, the only value that satisfies both conditions is y equals to 10. So, next, we move to step 3. Before this, we substitute the minimum value x equals to 15. Now we substitute minimum value y equals to 10. So, same like before this. So 12x plus 18y less than or equal to 360. So substitute y with 10. So 12x plus 18 and the bracket 10 less than or equal to 360. So now we want to know the value of x. So after we solve 12x plus 180 less than or equal to 360. So we've moved this into this. So 12x is to this. So the x is less than or equal to 50. So this means if you produce 10 units of y, you cannot produce more than 15 units of x without exceeding the same time limit. But from the minimum demand, x more than or equal to 15. Therefore, the correct value is x equals to 50. So, next we move to step 3. Check the other constraint. So we have to substitute the value that we cari tadi. So substitute y equals to 10 and x equals to 15 into 5x plus 8y less than or equal to 200. Before this we use time constraint, so this capital constraint. So So 5x plus 8y less than or equal to 200. So we substitute the value. So 5 in the bracket 15 and y is 10, right? So the value we solve in the left hand side, we must get less than or equal to 200. So barulah dissatisfied all constraint. So we solve this, we will get 155. So 155 is less than or equal to 200. So both values satisfy all the constraints. So the solution point is 15, 10. Okay, next. Okay, for graphical representation. So all the constraint we plot and get the straight line. So after we plot, we get the straight line. We will see the Point 5010 is found to be the only feasible point that meets all the conditions. So this is the intersection point lah. So this is meaning is the combination of production that still fits within the time and resource limits. Okay, from the calculation and graphical representation, we found that the optimal solution occurs when Aina prepares 5 bowls of laksa and 10 plates of nasi kerabu per day. So at this production level, all of Aina's constraints including capital, time and minimum demand are satisfied. Okay, so we move to objective function. We have to evaluate the objective function. So before this, we already know optimal solution dia 15, 10. So the objective function is z equals to 8x plus 10y. So we have to substitute this value into this equation. So we get x is 15 plus 10 in the bracket 10. So 8 multiplied with 15, we get 120 plus 10 multiplied with 10, we get 100. So this plus this, we get 220. So the maximum daily profit obtained is 220 ringgit. Calculated using the objective function z equals to 8x plus 10y. So this means that by producing 15 bowls of laksa and 10 plates of nasi kerabu, Aina can fully utilize her available resources efficiently while achieving the highest possible profit for her business. For conclusion, this study applied algebraic concepts such as linear equations, linear inequalities, and linear programming to solve a real-life problem. So this study shows that algebra can be used to solve real-life problems effectively by using linear inequalities, linear equations, linear inequalities, and linear programming. I was able to find the best combination of products that give Aina to highest profit. So the result proved that mathematics help us make logical and data-based decisions in business. Okay. A mathematical model was successfully developed to help Aina maximize her daily profit. The optimal solution occurs when Aina prepares 15 bowls of laksa and 10 plates of nasi kerabu, giving a maximum profit 220 ringgit. So this project shows that mathematics is not only theoretical but also a practical tool for a decision making in business. Mathematical modeling can also be applied in other fields of such as manufacturing, transportation, and financial planning. This approach can also be applied to other real-life situations such as managing time, resources, and production in different industries. Therefore, we can see that algebra is not just about solving numbers but about solving real problems in our daily life. So I think that's all for my presentation. Thank you very much.